Hi, this is Mel again, and today we're going to talk about Chapter 18 of Applications of Differentiation of Polynomials. So it's about the polynomial, which are the curves, and how we want to differentiate it, and some important features about the curve, such as local max, mean, and stationary point and stuff. So this is a summary. Okay, let's go through all of this. First, we want to talk about the tangent and the normals. So from previous knowledge, we know what's tangent and normal, right? For example, we have a curve like this. The tangent at this point is just the line just crossing the point, which looks like this. And what about normal? The normal, which means perpendicular to the tangent line, something like this. So this one is a normal, and this one is a tangent to the curve at the point A, at this point A. Okay, so it gives us some equations that we might need to remember. Let's see. So let point x1, y1 be the point of the curve on the curve, y equal to fx. If f is differentiable at x equal to x1, so what it's saying is at this point the function is differentiable, then we can say the equation of the tangent to the curve at this point is given by this equation. Or we can move the y1 to the right hand side. So you can write it as f dash x1. So this is the diff of function f at x1 times x minus x1 plus y1. So you can think of this y1 as a y-axis intercept, and this gives you the function of the equation of the tangent. Okay, what about the normal? So one important thing, as I mentioned earlier, is a tangent and the normal are perpendicular. They're always perpendicular to each other. So what does this give us? It gives us a very important property, which is their gradient multiply equals to -1. That's where this -1 comes from. Okay, so instead of writing the tangent like this, we write the normal with a -1 above the gradient of tangent. Okay, so the gradient, let's make it super clear. Gradient of tangent times multiplied by the gradient of normal is equal to -1. So if we have the gradient of normal like this, because the diff of a function represents the gradient of the function, right, at that point. So the normal is just -1 divided by the gradient of tangent, which gives us this one over here. Okay. So that's the basic equations for the tangent and normal at a point on the function if it's differentiable. Let's then talk about the stationary points. What's the definition of stationary points? It is if a point is stationary point, the coordinate FA is a stationary point if the first diff at point A is equal to 0. Or we can say the gradient at the point is equal to 0, right? We can say gradient at A is 0. Okay, there are some of stationary points, which we can call local max, local mean, and stationary point of inflection. This one is very different from the previous two. So let's talk about local max first. So local max is just like maximum, but locally maximum. Let's look at this graph over here. So if I have a function look like the curve, and if I say my domain is from, let's say, 0 to infinity, which is from this point and onwards, okay? What if I just say what's the maximum? Can you really tell from this graph? As it go from infinity, right? So we cannot say the maximum is the local maximum. That's a huge difference between them. So the local maximum represents as A. So this point is called local maximum because locally, from here to here, we can say it's local maximum, but it's not the most maximum of the graph. You can understand it as that way. And the local minimum is the same, but with minimum, right? So from this part of the graph, you can say point B is a local minimum. What about stationary point inflection? It's very different from local mean and max, which here is point C. So although it have a tangent of 0, which means at point C the first diff is 0, okay? But instead of like the local mean and local max, which you have increasing and then decreasing, or decreasing and then increasing, it have both sides of increasing. So the left-hand side of C, you have the graph increasing, and the right-hand side of C, you have the graph also increasing. That's a very unique point, which we call stationary point. So you can think of it as, at this point, if you have a ball over here, it won't roll up or roll down. So this point is stationary. And they tell us point A and B are turning points, which is true because you have one side going up and the other side going down. Okay, let's then talk about maximum and minimum value. So instead of local mean and local max, which we talk about over here, we have absolute mean and absolute maximum and absolute minimum, which will be restricted by your domain. So if we have a continuous function f defined on an interval from a to b, if m is a value of the function such that fx is smaller than m for all x belongs to from a to b, then m is the absolute maximum of the function. So let's maybe think of it as from a to b, we have, let's say, just linear, okay? So what it's saying is, from the graph, we can tell the absolute maximum is this point over here, right? This must be the absolute maximum under this domain. So all of the x, which are from a to b, is smaller or equal to the point m. So we have m coordinate as b dash m. So every single value from a to b is lower than the m over here. So that's what we call the point, this point, as the absolute maximum of the function. And same for n, point n. N is a value such that all the value from a to b is larger than n. So it should be this point, corresponds to a. So we have this point n. and this represents the absolute minimum of the function. So the difference of local min/max and absolute min/max depends on the domain you choose. And then it relates about motion in a straight line, which is something related to physics. If you have an object moving in a straight line with position x at time t, so we have velocity, which is speed with a direction, is equal to dx on dt. And acceleration is equal to dv dt, which you can think it as if you have x, if you diff once, you get v, velocity. If you diff twice, you get acceleration, which represents the change of your velocity. Okay, so that's something related with reality. And yeah, this is chapter 18 summary of math method, unit 1 and 2 of VCE subject. Okay, thanks for listening.